Hello dear students. In this video I will be talking about chemical bonding, chapter 6 section 1. Let's talk about it. Introduction to chemical bonding. Nearly all substances in nature consist of combination of atoms that held together by chemical bonds. In your room, you know there are carbon dioxides, oxygens. They're all substances consist of combination of atoms that held together by chemical bonds. Oxygen is made of what? Is made of O2 is made of two oxygen atoms that held together by chemical bonding. Salt that we use every day is NaCl, isn't it? Table salt. So it's made of sodium and chlorine atoms. Water is made of water is H2O. H2O is made up of hydrogen and oxygen elements. So the substances that we use every day, they're all made of atoms that held together by chemical bonds. Okay? So what is chemical bonding? Chemical bond is an electrical attraction between nuclei and valence electrons of different atoms that bind the atoms together. What does it mean? Look, if there are two atoms, when they get closer to each other, there will be an attraction between their valence electrons and their nuclei. So it says the electrical attraction between nuclei and valence electrons of different atoms that bind the atoms together, this is called chemical bonding. Sometimes because of this attraction, electron will be transferred from an atom to another, or sometimes they're going to be shared, right? So this is causes by electrical attraction between the nuclei and valence electron of different atoms. This is called chemical bonding. Okay. The question here, why most atoms are chemically bonded to each other? In nature, nearly all substances in nature are chemically bonded to each other. Why atoms they like to bond? Why it's rare to find a single atom in nature as independent particle. Why? Because atoms as independent particles, they are less stable and have high potential energy. By bonding with each other, potential energy of atoms decrease, thereby creating more stable arrangement of matter. So, as independent particles, atoms, they're what? They are less stable, they have high potential energy. So, they're not stable. Atoms, they're happy when they're stable. So, how they can become stable? When their potential energy decreases. How their potential energy decreases? By bonding with each other. So when atoms bond with each other, their potential energy decreases. This causes the what? The atoms become more stable. That's why atoms, they bond with each other. Okay? So there are three types of chemical bonding. We have many. But these are the main types of chemical bonding: ionic bond, covalent bond, and metallic bond. Later we will talk about the difference between these and why they are different. This causes the way in which electrons are distributed between two atoms determines the types of bonding. Okay? Let's talk about ionic bonding and covalent bonding. Metallic bond we're going to learn in section 4. Okay? What's ionic bonding? What's covalent bonding? Ionic bonding is electrical attraction between metals and nonmetals. When two atoms, a metal and a nonmetal, when they get closer to each other, what happens? A metal loses its valence electron, and a nonmetal gains the valence electron of the metals. So metals, they lose their valence electrons, and nonmetals, they gain. So when they get closer to each other. So when metals, they lose, they become cations. We learned that why it becomes cation, because number of protons going to be more than the electrons, so we give it positive charge. Okay, metals lose electron to form cations, nonmetals gain electron to form anions. When an atom gains electron, is going to the electron and protons, they're not going to be equal. The number of electrons going to be more than the number of protons. So if we have one, for example, chlorine, it has 17 protons, 17 electrons. When it gains one electron from sodium here, so the number of electrons going to be 18, and the protons number stays same, right? So 18 electrons, 17 protons. So at this time, as we mentioned in chapter 5, section 3, so we have one more electron compared to protons, so we give the one negatively charged. Okay, but sodium, which is a metal, to have 8 electrons in the last shell. We will talk about octet rule later in section 2. Okay, so metals, they like to lose electron to have 8 electrons in the last shell. So sodium here, it loses 1 electron to chlorine, and it becomes 1 positively charged ion because it has lost 1 electron. That's it. So why, in other words, we can say nonmetals, they have high electron negativity compared to metals. Okay, nonmetals, they have high electron negativity. We said, what does mean electron negativity? Means when an atom has high ability to attract electron from another atom. So the one that has high electron negativity, it has high ability to attract electron from another atom. Nonmetals, generally, they have high electron negativity compared to metals. So nonmetals, they take electron from metals because they have high attraction to take electron from metals. So metals, they have low electron negativity. So here what you must know. Ionic bonding is between metal and nonmetals. When a metal and a nonmetal, they get closer, metals, they lose electrons, and nonmetals, they gain. So there is transferring electrons in ionic bonding. Okay, that's it. What about covalent bonding? It's formed by sharing electrons pairs between two nonmetal atoms. First of all, you must know, when two nonmetals, they get closer to each other, they're going to share electrons. Why? Because both of them, they need electrons. They like to gain electron to their last shell be filled. And in other words, we say both, they have high electron negativity. They have high ability to attract electrons from different atoms, from another atom. So when they get closer, both of them, they have attraction to their valence electrons. At this time, they're going to what? They're going to share their electrons instead of one loses, one gain, because both of them, they have high attractions. But between a metal and a nonmetal, metals, they don't have high ability to attract electrons from nonmetals, but nonmetals, they have high ability because they have high electron negativity. At this time, metals, they lose, nonmetals, they gain. But in covalent bonding, no, both of them, they have high ability to attract electrons. So at this time, none of them lose, none of them gain. They don't have that ability. So they're going to what? They're going to share it. Okay, so n pair electrons, n pair mean one, they're going to what? They're going to be pair. Pair means what? Two. So when you say electron pairs, sometimes we have one pair, which is single bond. Later we'll like talk about two pairs. Sometimes two different atoms, they share two pair of electrons, means four electrons. Sometimes they share six electrons, three pair of electrons. Okay, this is the difference between ionic bonding and covalent bonding. Ionic bond between metal and non-metal, covalent bond between non-metals. There's sharing of electrons in covalent bond, but in ionic bonding there's transferring of electrons. Okay, types of covalent bonding. Actually, there are two types of covalent bonding: nonpolar and polar. Nonpolars, the atoms, they're going to share their electrons equally in nonpolar. But in polar covalent bonds, electrons are unequally shared. What does this mean? When two nonmetals is covalent bond, both, and it means both, it's between nonmetals. But you know, when the two nonmetals, their electronegativity difference is very small, means their ability to attract electrons, the difference between their ability is very close, between 0 to 0.3, the difference between their, at this time they're going to share their electrons equally. Look at here. Here, this is these two, they have shared electrons equally. But here in polar covalent bonds, there is unequally shared. What does mean unequally shared? When two nonmetals, they bond and they share their electrons, but one of them, its electronegativity is more than the other one by more than 0.3 to 1.7, the difference. And the difference between their ability to attract electrons means their electronegativity is between 0.3 to 1.7. The difference between there means the one that has high electronegativity, where the electrons are closer to that one. Look, the electrons in this bond are closer to the more electronegative atom. So the one that has high electronegativity, the electrons are closer to that. Why? Because they have high attraction. They attract the shared electrons to itself. Okay? Then at this time, electrons, they are closer to the one that has high electronegativity. And the electrons are going to be farther from the one that has the least electronegativity, lower electronegativity. So then poles going to form. That's why we say polar means having undistribution of charge. Uneven distribution of charge means there will be electrons going to not be equally shared. Electrons going to be closer to the one that has high electronegativity. Okay, the one that has more electronegativity, has a partially negative charge. We give it partially negative, means because electrons are closer, they're closer to them. So that's why we give it partially negative. And the one that the electrons are closer to it, we give it partially positive. We say it has partially lost the electrons, but it's not partially, because shared electrons, they are farther from that one. We say it has partially lost the electrons, but not completely. Completely gaining, completely losing happens in ionic bonding. But in polar covalent bond, electrons, they are closer to the highest electronegative element. Okay, that's it. Determine the types of bonding. Okay, the types of bond between atoms is determined by the difference in electronegativity. In the exam, if there are two atoms, how we know the bond between them is going to be ionic, is going to be covalent, is going to be polar or non-polar covalent bond? How do we know? By knowing the difference between electronegativity. You must know this figure. Look. You must memorize this. It says, if the difference between electronegativity of two atoms they're bonded to each other is between 0 to 0.3, the bond is nonpolar. If the difference is between 0.3 to 1.7, the bond is polar. If it's between 1.7 to 3.3, it's ionic bond. Look, it must be greater than 1.7, okay? Then it's going to be ionic bond. Look at this example. The bond between fluorine with an electronegativity of 4. The electronegativity of fluorine is 4. Cesium is 0.7. Okay? So how we know the bond, which bond is between them? By calculating the difference between their electronegativity. So between fluorine, okay, cesium and fluorine, what bond is between them? So the electronegativity of fluorine is 4, cesium is 0.7 Basha. The difference between electronegativity of these two, how we find large number, 4 minus 0.7 equals what? 3.3. The difference between their electronegativity, the difference between their ability to attract electron from other atoms is 0.3. 0.3 is what? Is ionic, because greater than 1.7 is going to be ionic, the difference between electron negativity. Okay, we have some questions here. Sample problem 1. Use electron negativity difference and figure 2, this is the figure 2, to classify bond between sulfur and the following elements: hydrogen, cesium, and chlorine. Here, look. The bond between, what bond is between sulfur and hydrogen? What bond is between them? You must know their electronegativity. Electronegativity will be given in the exam, okay? Don't worry. Sulfur electronegative is 2.5. What about hydrogen? Hydrogen is 2.1. So the difference is 2.5 minus 2.1. Okay? Is what? Equals 0.4. So if it's 0.4, the bond is what? Look, between 0.3 to 1.7 is polar. So the bond is polar covalent bond. It's polar covalent bond. What about between sulfur and cesium? Basha, sulfur is 2.5. We must find or calculate the difference in electronegativity. Then we can indicate the type of bond. So 2.5 minus cesium is 0.7. So 0.7. So it's going to be 1.8, isn't it? 0.7, okay, 3, then yeah, 0.8. If it's 1.8, 1 point here is here, so the bond is ionic. Okay, good. Sulfur and chlorine. Sulfur again is here. You must know something. Chlorine is 3. Sulfur is 2.5, so you must write like that. 3 minus 2.5. 3 minus 2.5 equals 0.5. So 3 minus 2.5. Okay, if 0.5 is polar. Okay, here it's again is polar. Here is ionic. Here again is polar. Here it says more negative atom. More negative atom means the one that has higher electron negativity. Between sulfur and hydrogen, which one has the highest electron negativity? Sulfur. So sulfur is what? Is the more negative atom, or we can say the one that the electrons are closer to it. So sulfur and cesium, again sulfur, the one that has high electron negativity. Here chlorine is 3, so chlorine will be, okay, that's it. Here also you can do the others between chlorine and calcium, chlorine and oxygen, chlorine and bromine. The difference, you're going to write the electron negativity difference, 3 minus 1. Calcium electron negativity is 1, chlorine is 3, is equals 2. If it's 2 to here, right? So the type is ionic. 3.5 minus 3. Oxygen 3.5, chlorine is 3, is 0.5. 0.5 is again is polar. Here the difference equals 0.2. 0.2 is nonpolar covalent bond. And the more negative atom means the one that has higher electron negativity. That's it. And these are the section review answers. Okay, inshallah, next video we will talk about chapter 6, section 2, covalent bonding and molecular compounds. See you.